So today's presentation is going to be covering Tacoma Power's Public Safety Power Shutoff Tool as my final project for our Master's GIS program here at the University of Arizona. In today's presentation, we will identify the research question, review the introduction of the project, become familiar with the study area, explore methods, analysis, and finally the results. We will move over to references and have time for questions at the end. So the goal of this project is to understand the relationship between wildfires, power, and water utilities for emergency management offices across multiple organizations, and to create a user-friendly application specific to the effects of a public safety power shutoff, or a PSPS, on Tacoma Power energized infrastructure. More specifically, the effect on water utilities throughout the service territory. By looking at the potential impacts of the community, if a wildfire caused Tacoma Power to implement a PSPS, which water purveyors would be affected? This information is vital to help mitigate firefighting impacts, as we've recently seen in wildfires throughout the West Coast. With this specific topic being a real-life application, the main question, which water purveyors would be affected during a PSPS within Tacoma Power service territory? It is merely a starting point for this application. Due to the sensitivity of information within the utility, there are elements that cannot be fully evaluated and included during the project and presentation. I chose to focus on the topic of wildfire impacts on community infrastructure systems to include electric utilities, water utilities, and fire agencies because of my current role at Tacoma Power as an emergency manager. This project focused on creating a real-world application with the goal of implementing it into Tacoma Power's Emergency Manager Toolbox. In regions throughout the West Coast, a combination of weather phenomena and electrical infrastructure have contributed to some of the largest, costliest, and deadliest fires seen in recent years. In an effort to mitigate the electrical infrastructure from contributing to the ignition sources of these fires, utilities have been tasked with creating wildfire mitigation plans to include public safety power shutoffs. So what is a PSPS? Washington's Department of Commerce describes a PSPS as a last resort measure that utilities use to proactively shut off power to specific lines in high-risk areas during extreme fire weather. This helps reduce the number of wildfires sparked by electrical systems. As the image indicates, when there is an increase in wildfire risk conditions, an electric utility must begin planning efforts to determine the location and timing of de-energization. These types of decisions have downstream effects on everything from powering your home, transportation, businesses, healthcare, and water services, to name a few. As the title of this presentation indicates, Tacoma Power service territory is the area of focus for this project. My focus is on the elements that would be impacted by Tacoma Power enacting a PSPS. Tacoma Power serves the city of Tacoma, University Place, Fircrest, Fife, and provides services to parts of unincorporated Pierce County. The service territory is located within Pierce County, Washington, as indicated with the dark red polygon boundary. A region which includes a diverse geographical landscape ranging from the Puget Sound's body of inland waterways to urban environments, brushing up to the forested boundaries of the more rural areas surrounding Mount Rainier. Tacoma Power falls under Tacoma Public Utilities, or TPU, which includes power, water, and rail. Its service territory is 180 square miles within Pierce County. Additionally, Tacoma Power owns and operates 4 hydroelectric dam projects located in 6 counties throughout Western Washington. And while I'm talking about the hydroelectric dam projects, it is important to point out that the transmission lines that carry energy from the hydro projects come in from the northwest and southern directions of the service territory. Unfortunately, this is part of the information that is considered proprietary and cannot be documented during this presentation. Once the research question had been identified, the next step was to create a general outline of the remaining project. The initial step, identifying the project where I needed to request software and account access on the Tacoma Power's GIS side, as well as acquire necessary data. Additionally, identifying the application to utilize throughout this project. The next major step focused on prepping data, using the selection by location tool set within Tacoma Power Service Territory layers through ArcGIS Pro and prep data to move into a web layer in preparation for creating a web map. Next, bringing the data from ArcGIS Pro to ArcGIS Online's Experience Builder. After inserting the web map layers, identifying functions that would be included. This identifies which widgets can be incorporated into the dashboard. Finally, the grayed out section illustrates how this tool will be continued on after this project's presentation. I will be handing this over to the GIS team at Tacoma Power to plug in the utility-specific data, where it will be released to a beta test group, collect feedback, and implement any necessary edits. Starting off in ArcGIS Pro, the main layers included are Tacoma Power Service Territory, with both north and south service areas identified. This layer is the primary layer used for the entire project. Also, the boundary lines are used as perimeters for making selections within the water purveyors layer. Here we see the water purveyors that fall within the Tacoma Power Service Territory in black outline. There are water purveyors that exceed the perimeter, and that is due to the water provider service area extending into multiple power utility regions outside of Tacoma Power. In a similar fashion to the water purveyors layer, the fire stations within the boundary lines were also included. Fire stations were included as their main tool for fighting fires is water access, which is connected directly to the water purveyors. The map on the right shows all the layers together within the Experience Builder web map. The first part of the analysis looks at the first page of the PSPS tool, which opens up to a map with all three layers shown together. In the bottom left corner, a business analysis widget is included, an interactive component for users to type in a specific location, identify the buffer radius, and select the specified infographics. An option for infographics is emergency information, which includes information like population, housing numbers, facilities, including critical infrastructures, and identified at-risk demographic information. Here we see that populated result of the emergency information infographics image. This pulls real-time data using the parameters outlined on the buffer tool and create an image that is easy to read. The second page, titled POCs, or point of contacts, is another interactive tool where the two other layers, water purveyors and fire stations in Tacoma Power Service Territory, can be selected based on the user's selection. The respective organization's contact information is then populated. The POC information is an integral part of the coordination efforts for emergency managers to alert the respective areas of potential impacts to other services, like water and fire. The final page pulls live data from Esri's Live Atlas U.S. Wildfire Activity Map, illustrating real-time wildfires and information associated. Additionally, there are 3 buttons at the bottom to include direct links to the Watch Duty app, Washington's Department of Natural Resources Burn portal, and the final button is a placeholder for an internal dashboard for Tacoma Public Utilities, which houses a situational awareness dashboard. On the far right sidebar is a live feed of Tacoma Power's outage map page. Included in the map highlights both planned and unplanned outages within the service territory, as well as any live fire activity feed. In developing this process, I had to work within the constraints of proprietary information in order to solve the problem for emergency management. A user-friendly application was created to bridge the gap between power and water utilities, fire agencies, and emergency managers to understand potential impacts to resources necessary in fighting wildfires together. Resources on wildfire data, community demographics, and utility service areas serve as the main elements within the application to paint a picture of a whole community approach to mitigating and preparing for a potential PSPS due to a wildfire. The tool is interactive, allowing users to identify a location that would potentially be affected by an impending wildfire, identify the services that would be disrupted if a PSPS had to be implemented, and have access to resources like contact information to those agencies affected. As this project is just the starting point, the results are broken up into current and future results for both internal and external users. Internal members at Tacoma Power and external for entities like Pierce County's Department of Emergency Management, water purveyors, and fire agencies alike. Fire agencies and water purveyors throughout Tacoma Power's service territory have been identified proactively to begin mitigation efforts and conversations in the event of a PSPS implementation. Moving forward, as the project is released to the Tacoma Power's GIS team, utility-specific information will be included to produce a more granular projection of impacts to critical infrastructure. This invites collaboration opportunities between utilities, fire agencies, and emergency managers alike throughout the county. This is just a quick list of references for the specific presentation, including a link to the published Experience Builder Tacoma Power PSPS tool at the bottom. That concludes the main portion of today's presentation. We have time left for some questions, so thank you.